So here we have the function 2 sine x degree minus sine 2x degree divided by x cubed. We have to find its limiting value. Now here x is in degrees, whereas x simply x, that is in radians. So that means we'll have to convert the degrees into radians. But before that, let us try to simplify the numerator. So we have limit x tending to 0 2 sine x degrees minus, now sine 2x is an identity which can be expanded as 2 times sine x degrees times cosine of x degrees divided by x cube. Now we are going to take 2 sine x degree as the common factor in the numerator. So that is going to leave us with 1 minus cosine of x degree divided by x cubed. Now we have 1 minus cosine of x is equals to 2 times sine of x over 2. So we're going to use this identity that will give us sine, the limit x tending to 0, 2 times sine x degrees times 2 sine, so we have x degree here, so we're going to replace it by x degree over 2 divided by x cube. So that is going to give us, let's bring 2 times 2 is 4, let's bring the 4 to the front of the limit. So we have limit x tending to 0, so we have sine x cubed. Now x cubed can be decomposed as the product of x multiplied to itself 3 times. So we have sine x degree over x times sine x degrees over 2 divided by x times sine x degree over 2 divided by x. So we know that x degrees, 180 degrees is equals to pi radian. So that means 1 degree will be pi over 180, and that means x degrees will be pi x over 180. So we're going to replace x degree by pi x over 180. That gives us 4 times limit x tending to 0 sine pi x over 180 divided by x times sine x degree over 2 will become pi x over 2 times 180, which is 360 times divided by x times sine pi x over 360 divided by x. Now what we're going to do here is we are going to multiply the first function, sine pi x over 180 divided by x. So we're going to multiply the denominator x by pi over 180. So since this is an extra term, so we have to multiply by pi over 180. Similarly, for the second function, we multiply pi over 360. So that means we'll need to multiply the entire function by pi over 360. And finally, for the third function, we multiply the denominator with pi over 360. So that means we have to multiply the entire function with pi over 360. Now we multiply all the constants. So we have 4 times pi over 180 times pi over 360 times pi over 360. And the limiting value of each of the functions are going to be 1, because we are using the definition here that limit x tending to 0 sine x over x is equals to 1. So let's multiply this. So we have 4 times pi cube divided by So 180 times 360 times 360. Before that, we can do one more thing. So we can cancel out this 4 with the 360. So 4 times 90 is 360. So we can get rid of this 4 in the numerator. So we'll have 190 times 180 times 360. So this is going to be the limiting value of a given function when x tends to 0. Or we can further, what we can do is pi cube. So pi over 180 whole cube. So this is going to be the final answer. Let us do another problem. So in this particular question, we are going to use the identity. So we'll consider the first two terms, sine a plus x plus sine a minus x. So we're going to combine it using the identity, the sine of a plus sine of b equals 2 times sine of a plus b over 2 times cosine of a minus b over 2. So that will give us limit x approaching 0. So we have 2 times sine a plus x, so this is a, plus b, which is a minus x, over 2 times cosine of a plus x minus a plus x divided by 2 minus 2 times sine of a divided by x times sine x. Now here we see that x and x gets cancelled, leaving us twice a over 2, so that will be a, and we have a and negative a cancelling out each other, leaving us with 2x over 2, so that was going to give us cosine of x. So let us write it down. So we have limit x approaching 0, 2 times sine of a times cosine of x minus 2 times sine of a divided by x times sine of x. Now we can take 2 sine a as the common factor in the numerator. What we're going to do, we're going to take negative 2 sine a over. So we have limit x approaching 0, negative 2 sine a, sine a times 1 minus cosine of x divided by x sine x. Now here we're going to use two identity. So the first identity that we're going to use is 1 minus cosine of x is equals to 2 times sine squared x over 2, and sine of x is equals to 2 times sine of x over 2 times cosine of x over 2. Okay, let's substitute this value into our given function. So that will give us limit x approaching 0, negative 2 sine a times 2 sine squared x. So let me write, instead of sine squared x by 2, let me write it as the product of sine x over 2 and sine x over 2. That will be evident in a moment. Now we have x times 2 times sine x over 2 times cosine of x over 2. So we can now cancel out sine x over 2 from both the numerator and the denominator, and we can also cancel out the 2. So that leaves us with sine x over 2 over cos x over 2. So this ratio is tangent of x over 2, and the rest of the remaining terms So we have limit x approaching 0. So we can take the negative 2 to the front of the limit, as well as we can also take sine a. So we have negative 2 sine a times limit x tending to 0. So sine x over 2 divided by cos x over 2 will be tangent of x over 2 divided by x. Now what we need is an x over 2 in the denominator, so we divide x by 2, so that means we'll have to multiply by half. So we can take the half to the front, so negative 2 multiplied by half is going to give us negative 1. So we're left with negative sine a times limit x tending to 0 tangent of x over 2 divided by x over 2. So this is by definition. So we have limit x tending to 0 tangent of x over 2 over x over 2. So what we're going to do here, we're going to use the definition that tangent of x over x is going to be equals to 1. So we have negative sine a times 1, which is negative sine a. So this is the limiting value of the given function when x approaches 0. So here we have the function tan 3x minus 2x divided by 3x minus sine squared x. So here we are going to convert the tangent function to the ratio sine over cos. So we have sine 3x over cosine of 3x minus twice of x divided by thrice x minus sine squared x. And we combine the two terms in the numerator, and that will give us sine 3x minus twice x times cosine of x divided by cosine of x, cosine of 3x. So what we have a cosine of 3x here multiplied to 3x minus sine squared x. Now we're going to divide the numerator and the denominator by x. So that is going to give us limit x approaching 0. So we have sine 3x over x minus, so 2x over x is simply going to give us 2. So we have 2 times cosine of 3x divided by cosine of 3x. So we have 3x over x, which is going to be 3 minus sine squared x over x. Now we are going to rearrange. Now here what we can do here is we can multiply the numerator x by 3. So that means we have to multiply the function by 3. Similarly, here we can multiply by x squared, and then we have to multiply by x. Now we're going to calculate the individual limits. So that means, so in the numerator we have 3 times the limit x tending to 0 sine 3x over 3x minus 2 times the limit x tending to 0 cosine of 3x divided by limit x tending to 0 cosine of 3x times limiting value of 3 will be 3 minus limit x tending to 0 x multiplied to the limit x tending to 0 sine x over x whole squared. So that will give us 3 times the limiting value of sine 3x over 3x is going to be 1 minus 2 times cosine of 0 divided by cosine of 0 times 3 minus limiting value of x is going to be 0 times limiting value of sine x over x is 1. So that gives us 3 minus 2 divided by 1 multiplied to 3. So we have a limiting value of 1 over 3 for the given function when x goes to 0. So in this particular question, it is given that the limiting value of the function kx times cosec x equals to limiting value of the function x cosec kx. In both the cases, x approaches 0. So we have to find the value of the constant k. So let us begin. So we have k times the limit x approaching 0 times x cosec x equals to limit x approaching 0 x times cosec kx. Now we know that the cosec function is the reciprocal of the sine function, so we can rewrite it as limit x approaching 0 x over sine x, which will be equals to limit x approaching 0 x over sine kx. Now what we're going to do for the second function on the right hand side, we're going to multiply the numerator by k and divide by k. So that is going to give us, so k times, so the limiting value of x over sine x is 1, which is equals to 1 over times the limiting value of the function kx over sine kx, which is also equals to 1. So that means we have k over 1 over k, which implies k squared is equals to 1. Then we're going to take the square root on both sides. So this is going to give us k equals to -1 and +1. So this is the final answer. Let us move on to the next question. So here we have the given function and we need to find its limiting value when x approaches 0. So we begin by factorizing the numerator and the denominator by splitting the middle term. So this will give us limit x approaching 0. So we have 2 sine squared x plus, so sine x can be written as 2 sine x minus sine minus 1 divided by 2 sine squared x. So we have -3 sine x, so that will be -2 sine x minus sine x plus 1, which will be equals to limit x approaching 0. So we're going to factor out 2 sine x from the first two terms, and that is going to leave us with sine x plus 1, and then we're going to factor out -1 from both from the third and the fourth term, so that is going to leave us with sine x plus 1. Similarly, in the denominator we are going to factor out 2 sine x from the first two terms, so that is going to leave us with sine x plus 1, and we're going to take -1 as the common factor, so that was going to leave us with sine x minus 1. So we have limit x approaching 0 sine x plus 1 multiplied to sine x minus 1 divided by sine x minus 1 times sine 2 sine x minus 1. So we can now factor out sine x minus 1 from both the numerator and the denominator, and that leaves us with limit x tending to 0 sine x plus 1 divided by 2 sine x minus 1. Now we substitute for the value of x, so we have sine of 0, which is going to be 1, divided by 2 times sine of 0 is going to be 0, so we have -1 in the denominator. So we get the limiting value of -1 for the given function when x approaches 0.